Good afternoon, and thank you for joining us. I am Jesse Levinson, the co-founder and CTO of Zoox. I'm here with Chi Homas, our Senior Director of System Design and Mission Assurance, and if you don't know what that means, you'll find out very soon. And we're here to talk about safety and system design at Zoox, a little bit about what that means in general in the industry, and then, of course, some specifics about what that means for Zoox and how we're unique in the industry in some ways. So really excited to have you with us this afternoon, and I'll turn it over to Chi to introduce herself.
Thank you, Jesse. Hello, everyone. Really glad to be here with you. I am Chi Homas. I'm the Senior Director for System Design and Mission Assurance. I've been with Zoox for nearly 4 years now, helping building up a highly capable, dedicated team of professional safety engineers who work on the safety case for the Zoox autonomous driving technology. And the team has grown quite a bit since I joined, and our focus is kind of across all of the technology and the operation domains within Zoox. Prior to joining Zoox, I was with Waymo. I built Waymo's first system safety team, and we were part of the launch for the very first Waymo One service in Chandler, Arizona. My prior experience also includes working with the special project group at Apple. Prior to the Silicon Valley experience, as you can see in my LinkedIn profile, I taught systems safety and systems engineering at MIT for about 6 years, where I had the opportunity to supervise a number of theses that spanned across multiple industries, including medical device, airplane design, military systems, etc. Learned a lot from that. And I had spent a couple of years with US DOT, Department of Transportation, helping advise the rulemaking team there about how to think about the safety of automotive control systems. There I learned a lot of perspectives of the regulators and how they look at industry. So I'm very glad here to be with Zoox, and I feel this is a very special place for someone who really cares about systems and safety.
Great. Now, speaking of systems, how would you describe what system design is to somebody who might be interested but not super familiar with the concept?
I love this question. I would say you look at my LinkedIn profile, you see I've been everywhere, all kinds of places, as if I was seeking for the right place. Really, what you don't see in LinkedIn is what was motivating my whole career. Since I was an undergrad engineering student, in my very first internship, what really fascinated me were the how humans come together, work together in a large group, design very complex technology, and take that to realization. So think about how we landed on the moon, how we ended up being able to fly around the globe, getting everywhere, within a day. How did we go to the deep sea? How did we harness nuclear power? These things, as an individual, when you think about it, it seems impossible. Yet they're all real in our lives, right? We're very used to them. So the system design, how the different technology come together, subsystems interact to create something bigger than just the sum of the components individually, how a diverse group of people with very different background come together, learn to work together, and produce something that bigger than each individual can produce. The dynamics in the organization, people's interactions, the drama, the trials, the triumph, and the tragedy that comes with it. I always think that's it's extremely fascinating. And my whole career has been centered around learning more about various aspects of the system. And so coming back down to system design and the mission assurance adds to the system design piece to say, hey, in this very complex system, there are goals, there are mission goals. And that means we gotta have requirements, we gotta have measurable targets and metrics, and we gotta have evidence that we've met our goals and this is the system we want. For Zoox, the SDMA's mission currently is very focused on building the overall safety case, because safety is foundational for Zoox. Without safety, there is no autonomous driving to talk about. We don't want to put anything on the road to actually create more damage or less safe. So so that's what system design mission assurance is for. We set the safety metrics for every milestone for autonomous operation. We verify and validate that we actually met the safety metrics.
Great. So you have obviously worked not only in the AV industry for a long time, but as you pointed out, in many areas of complex system design. What's something kind of unique about SDMA at Zoox? Because we did build our own ground-up Robotaxi, which we're still the only company in the world that's done that. It's a lot of work, took a lot of time, money, people, but we're excited because it's been driving on public roads now for a couple of years,
Yes.
And recently in San Francisco and Las Vegas, including on the Strip. So, some of system design is going to be common at any company working on driverless vehicles. What's kind of special about it at Zoox because of the fact that we built our own vehicle in addition to doing the firmware and the AI and the cloud software and all of that?
Yeah, that's a great question. The first time I saw Zoox and heard about Zoox's concept, it was very inspiring and fascinating to me because coming from a systems background, the safety of a system really can only be talked about as a whole system. There is no safety at the component level. You cannot talk about, for example, the safety of a sensor, a LiDAR. How safe is this LiDAR? Without talking about what's the platform is going on, how are you going to place it, how AI software is going to work with this, and what's the operating environment and our operations. So Zoox made the conscious choice, I think, since the founding days, Jesse, to have the full design in-house. And that allows us to be able to optimize the whole system for safety and many other metrics. Why is that important? One is obviously optimizing means being able to have freedom in choices in design when we create something. So we get to decide what kind of brakes we want to have, what kind of electronic drive units is important.
And sometimes we have multiple copies of them, which you don't have in the car, right?
Absolutely. Redundancy to ensure safety. How do we design safety into the design decision in the first place so that it's not an afterthought for Zoox? So that is very important to optimize. The other side, perhaps fewer people think about, is when you have the entire system, kind of all the levers you can adjust and pull. It creates a condition for us to optimize the top level goal by choosing the smartest solution that is the most effective, most efficient, let us to get out there fastest without sacrificing the top level goal. So if we don't own the whole platform, the whole vehicle, we will have less, more limited choice to make.
Great.
So when I first met you, Jesse, the first time, I wasn't thinking about leaving Waymo. Our recruiter reached out to me and I said, oh, Jesse, the co-founder of a Silicon Valley company, let me talk to him, see what he has to say. Within maybe 2 sentences, you started mentioning safety and this vision for an organization called the SDMA. That really caught my attention. Could you share with everyone how did you think about SDMA and why you think that was important when we first started talking?
Sure. So I've been working on autonomous driving for, believe it or not, almost 20 years now. It's 19 point something. I don't remember the exact day, but it's coming up on 2 decades, which is kind of bizarre to think about. In the beginning, it was super early days. So it was more like, hey, how can we get, this self-driving car to do something cool, right? Like, how can we, do a right turn or a left turn or detect a traffic light and kind of get the basics to work. But eventually, if you think about the end goal, which is to not need a human in the vehicle to drive the thing, it's less about, how do we make things work and more about how do we make sure that things always work, right? Make sure things never don't work. And it's that transition, right, where you go from, like, we just have to build stuff and, if we can sometimes give a demo, like, congratulations, right, to, no, this is like, going to run unsupervised and it's going to work no matter what happens in the environment. That transition is actually even more about, safety and assurance than it is about, doing cool engineering work and developing new stuff, right? Now, you have to do that to get the safety, but I actually think that the hardest part is, defining those requirements, figuring out how you're going to test and validate them, including on millions of miles of real data, plus way more than that of simulation. And how do you make sure you're simulating the right things? And how do you make sure that when you come up with the really dangerous scenario you've never seen, that you can have some estimate of how often does that occur, and how do you put that all together in what we call a safety case, which is a really comprehensive set of documents that put together tell you that you've done the right things from a system engineering perspective, you've followed all the known industry best practices for how to build complex safety critical systems. But that's not enough, because until very recently nobody's put robots out there in the world that could hurt people if things go wrong. So we also have to do this quantitative risk assessment where we're estimating, the probability and rate of bad things happening, and having to do that with various different sets of partial information. So putting that all together and then building a culture inside the company where that's not seen as like, adversarial or like, oh no, like the safety people are coming, but actually flipping the model where it's like, let's all agree that not only is safety first, because that's an easy thing to say, but what does that mean? How do we align on our ambitious safety targets, agree on how we're going to measure, and then there's no debate along the way, about what the targets are or whether we're good enough. And instead of, the debate being, well, we hit our target date, so, is it good enough? Well, it's pretty close, like, let's see what happens, or, well, maybe if we only drive this many miles, the total risk, like, we don't do that at Zoox, right? We have a very rigorous standards by which we say, look, until we hit these safety numbers in aggregate, which take into account all possible sources of risk, we're just not going to do that thing, right? And that's foundational in our culture. It's foundational in the way we do engineering. And so, Chi and I got to talk about that 4 years ago, but of course, we weren't very far along with it 4 years ago. We weren't operating vehicles autonomously on public roads without safety drivers when you joined us. And
That's
so
right.
The journey over the last 4 years to take the concepts that we talked about when you interviewed and then build a great team and then do tons of testing and validation while improving the vehicle and the AI and the firmware and everything. That's just been an incredible 4 years. I'm really thankful to have had you leading that team, because it's just pretty amazing what happens when you put all those pieces together.
Thank you, Jesse. It's been a privilege. I also want to say big shout out to the SDMA team. It's not me, really. It's all of you joining us and hold up high bar for safety integrity in all of the decision makings, questioning the decision we made, finding data to either support or debate whether this is the right decision. It's a wonderful team we've built.
So speaking of teams, right? If you have the safety team off on some corner, right, that doesn't really work. So maybe you can talk a little bit about how do you both run SDMA, but also maybe even more interestingly, how do you get SDMA to work constructively and collaboratively with all the other engineering and operational teams at Zoox, so that we can all kind of go in the same direction and actually achieve these really ambitious targets?
Yeah, so I want to say not me. How do I? I think there's a very big context, which is what Jesse just said, how we approach safety at Zoox. From all the way from the top, our founders, our co-founders, our CEO, our top level leadership, our corporate goal, our founding principle is safety is foundational. We're going to put the technology into the public world that enhances safety, not to hurt other people. So if our product doesn't achieve that, there's no product. There is no product. That's a very clear and strong message in this company, and that permeates into every conversation, every decision. In every safety literature, because I've worked on the academic side, safety culture is the foundation. Without that, no matter how good a leader, how technical, how many analysis statistics I can do or my team can do, we will not have the safety outcome. So I want to say that very first. I think that context empowers SDMA to do good safety engineering. And the trust and credibility we earned are through, number one, close collaboration with our partner teams. understanding their challenges and get involved early. So we don't come in as a naysayer at the very end of the process and say, not good enough for safety. We actively set requirements, set metrics early on, understand the challenges, problem solve together. And so that safety is part of the design. And I would again say the team, SDMA team, are excellent engineers, and our analysis, our testing really earned the trust from the partner teams. Because these results are useful, the partner teams are able to really act on them and design the system proactively. The last component, I think, is very unique for Zoox. In addition to the safety culture and strong team, is we actually have a quantitative risk assessment model where we not only do good systems engineering, do good work early on, we add up all the residual risks in the system. We understand, we can quantify the total risk remaining in the system. That total risk guides the prioritization of engineering effort, where we've done enough, where we needed to put more resource on, and really help other team to move ahead together as one company towards our company goal. So I think these three components, the safety culture, the strong engineering team, as well as the quantification of risk, enables Zoox to be quite unique in this AV industry.
Mm-hmm. Great.
We're now in 2025, Jesse. We talk a lot about 2025, what it means to Zoox, what are the priorities. Would you like to share with us what's the biggest focus area and opportunities for SDMA in 2025?
So it is an exciting year, right? Because, we first started driving on public roads in February of 2023 with our ground-up Robotaxi. And, it's not that long ago, but at the time, we were here in Foster City. It was a weekend. We had approved our ODD for clear weather and dry roads. And it had rained, the night before, and, we were being very pedantic and meticulous. So we were like, well, we're all excited, ready to drive, but, the roads were a little bit too wet. And now we drive on wet roads.
We didn't validate that in safety case.
We were all like 99 point whatever % sure it would be fine, but, that wasn't in the approved, ODD. Right. So we said we have to wait. And then we put out, the Robotaxi first with nobody in it, and then Aish and I went in it, and then a bunch of us took rides, and it was a very quiet day on purpose, start really small. And the route, it had some real stuff, but it was relatively simple compared to, dense urban. And in, under 2 years from there, now we're running, dozens of the Robotaxis, not just in Foster City, all day, all night, but in, the dense parts of San Francisco, in the densest parts of Las Vegas, including the entire Strip, and now doing some of the major hotel pickup and drop-off. So that's been really, really cool to see that progress in the last 2 years. But this year, we're actually going to have our first external riders going by themselves. We've been doing friends and family over the last year, which is cool. But there's always a Zoox host in the vehicle. So this year, for the first time, we're going to have our Zoox Explorers, which are external riders with no particular affiliation to Zoox, and they're going to be able to get in a Zoox by themselves or with friends and go where they want to go within our geofence. Speaking of which, we're really expanding our geofences this year. Yes. So, we're proud of the hard driving we're doing, but we're not driving enough places for it to be very useful yet. So over the course of this year, we're going to be growing our geofences and actually making this service useful. And so that's a lot of work for system design and mission assurance, because we have to be able to basically clear entire large polygonal geofences, including anything that can happen with them, and dynamic routing within those bigger geofences. So we have to develop some new validation techniques. We have to run much larger scale simulations and data sets. And we're always, continuously improving our targets for safety, for reliability, and so, and then the software is improving, and so it's always busy. But we're really excited this year because getting our first true external riders is a big milestone for us.
Absolutely.
And we can't wait.
Absolutely.
So as we are, speaking of which, getting ready for commercial launch. What areas are you focused on hiring? Because we've grown SDMA a lot over the last few years since you've been here, but we're not done growing it. So what are some of the key areas that you're excited to continue to expand the team in this year?
So obviously, as a systems engineering focused team, we want to continue to grow systems engineering expertise to help the company shift left. What that means is get deeper involved with the AI software, the complexity in the technology. Get involved earlier on. So the validation, the testing strategy are based on true understanding of the challenges, the potential hazards in our design, and we can test early on. Best is before the code is committed and catch all those problems. So when they get to the main line and when we release, there's less and less surprise late on. The late surprise and the rework is the most costly and the delay all the releases. So that's one area. The second area, as you mentioned, Jesse, we're really going to welcome our customers for the first time. They're going to give us feedback. They're going to say, hey, this can be better. Hey, I didn't like this.
What? No, everything's going to be perfect. Come on.
Of course. We are going to have to be able to react fast. Any hotfix software or any change in operation, SDMA is always part of the safety assessment. We need to build that machinery to be able to react and enable the company to quickly react and to satisfy our customer and continue to earn their business and trust.
That's really important, right? Because on the one hand, anytime you change the software, you want to run lots and lots of comprehensive validations and simulations to make sure you don't have any regressions. On the other hand, you'd like to be able to make changes, especially if they're targeted changes, really quickly, so that you keep the vehicles in service and you don't have known risks outstanding. So that balance is really tough, actually. And so to improve both halves of that, we really need to actually work on our processes, our automation, our tooling, scaling up a lot of this. We're even doing some really cool work on using large foundation models to triage some of the results that we get out of our simulations instead of having to have hundreds of people look at thousands and tens of thousands of scenarios. So there's some really cool, interesting, innovative work happening that's going to allow us to be faster and safer at the same time.
Absolutely. So for SDMA, we're building up the service team, the reactive operational safety team. So that's another hiring focus. And the last one is technical program managers. We want to be able to run the program effectively, efficiently, and need a lot of support from the TPMs. So those are the three areas.
Great. Well, we're going to do audience questions now, which is the best part because people always surprise us with things we haven't prepared for. So we're going to turn it over to live Q&A. Don't be shy. And whatever question you have, even if you think maybe this isn't a great question, just ask away and we'll do our best to get to as many as possible. All right, first up, are there any industry standards for these safety requirements? Or does Waymo have its own criteria and Zoox another? Great question. Chi, do you want to take that one?
Yeah, I can take this one. I do not want to speak to Waymo. I've left Waymo 4 years ago, and they must have advanced a lot. We see them on the streets. They're doing great. So I can share how we do this at Zoox. Absolutely, all of our safety requirements are informed by industry standards. Industry standards are lessons learned from the past, very useful to incorporate. Industry standards, nonetheless, were written for a different kind of technology. So, for example, ISO 26262 were written by commercial passenger vehicles in mass-produced companies and with human drivers in there. We leverage that standards and the process, the practice in there, the metrics, extensively in our robot platform design.
And we talk about ASIL ratings a lot.
All the time.
Like we don't just oh, that's cute. No, like we talk about, ASIL B and ASIL D, like in many parts of our stack and hardware and software.
Absolutely. We have to go beyond that in order to deliver our technology. So there's a lot more we do beyond the safety standards. I know Waymo does the same. Industry standards are formed when the industry is pretty settled. The architecture, the maturity of the technologies are common practice we can share. So I'm sure AV companies at some point in the future, some years down the road, will have our own industry standards. Today, we learn from the best in the past, and we kind of have to write our own playbooks. Jesse, I think the next one is great for you. How do people sign up for Zoox Explorer program?
Good question. So we don't have an official sign-up page yet. The best thing you can do is go to Zoox.com, check out our newsletter, or sign up for our newsletter with your email address, and then you'll be the first to receive a link to sign up to be a Zoox Explorer. All right, next question. How do you balance the need to rapidly iterate and improve the technology while maintaining rigorous safety standards?
That's a great question. I love this question because there's an assumption behind this question. Is either or. You either slow down and be safe, or you go fast and be less safe. Actually, it's not that, right? So the speed to iterate and go fast is not necessarily in contradiction with being safe. So when you accept that and say, we have to be safe, but we also want to go fast. Hey, SDMA, we're part of Zoox. If Zoox doesn't succeed and we're super slow, we fail as a company, there's no more SDMA. We can't do our favorite work anymore. So with that in mind, this actually becomes the set of constraints for innovation. In SDMA, a lot of innovative approaches, methodologies were developed because we want to go fast and go safe. Things like, how do we run simulation more effectively? What would the statistics tell us how to efficiently sample our scenarios? So the most meaningful things are applied, and the useless empty miles are not run and wasting our time and the resources. Those are the questions we find the clever answers for and enable our teams to go fast. The next question, how does Zoox ensure the reliability and robustness of its autonomous driving software against unexpected scenarios? Maybe I get a start on this. There are a number of ways we anticipate what scenarios might happen in our driving experience in our ODD. We obviously drive in our ODD. We collect millions of miles of data, and we review these logs, and we rerun them with the latest software to see how our software is performing against those. And there are a lot of interesting scenarios involved in there. These scenarios then further inform us to say, hey, just because we're lucky, maybe this very moment, the combination of timing and everything, we didn't have a collision. What if people came out a little bit faster? What if our angle is a little bit different? We have another system where we set up synthetic scenarios and probe various design parameters, vary them, change them, simulate all combinations of them to identify whether there are potential safety risks. We also use structured hazard analysis to imagine what might happen. Just because we haven't seen it doesn't mean it will never happen in the real world. So we use techniques like STPA, System Theoretic Process Analysis. We use FMEA, fault tree analysis, to anticipate what might also happen. And those become the inputs to further develop synthetic scenarios.
Mm-hmm. On top of all of that, we also do live structured testing on test tracks. That's using test track dummies. Like, we have basically fake cars and fake humans that we can throw at the vehicle coming out of occluded objects. These are scenarios you wouldn't want to test in real life because they're really dangerous. You can test them in simulation, but you also want to make sure that in real life you're going to get very similar behavior to your simulation, otherwise the simulation is not that useful. So we do test those types of emergency scenarios. We have hundreds of them that we test on test tracks, and that's quite informative as well. Mm-hmm. All right. How does Zoox ensure the reliability and robustness of... Oh, no, we did that one.
We did that one. The next.
Last question. How do you define functional safety? This is a good one. How do you define functional safety for deep learning models, including detections and controls?
That's a very interesting question. I think of functional safety, if you're referring to ISO 26262, functional safety that standard isn't written for deep learning models. It's written for more traditional engineering systems, where you first write out the function and you say, if I failed that function, how do I ensure the safety? So redundancy, safety monitors, operational mitigation can come in as solutions and make sure those solutions are of high integrity. So when we talk about deep learning models, it really depends on where you're using them, what you're using them for, what function they're supporting. And depends on that function and where this function is allocated, you could apply that overall framework to say, hey, there's a function that's delivered by a deep learning model. If this function failed, what is my safety mitigation strategy? Mm-hmm. So this would be the way to apply that framework in our systems. Detection, absolutely, and the controls, yes. I think that's all naturally part of the functional safety toolbox that we can use.
Great, thank you, Chi. And thank you to everybody for tuning in today. Hopefully you enjoyed the conversation. It's a particularly exciting time at Zoox as we continue to scale. And we are hiring across several teams, not just SDMA, but broadly across the company. Most of us are here in the Bay Area, but we also have folks in Las Vegas, Seattle, Boston, and San Diego. So if you're interested in joining the crew, please take a look at our job postings on our career page. You can access that via the QR code on your screen or just take a look at the Zoox.com website. So thanks again, and have a great rest of your week.
Thank you all.